This is the Henderson, a new skyscraper in Hong Kong built on the most expensive site in the world. But this building has far more to it than just its insane price tag. It was constructed during a typhoon, its complicated facade could only be produced in Germany, and it's designed to fend off the bad Feng Shui of its neighbours. It's a structure that fuses together the old and the new while being on the very cutting edge of construction tech. It's an epic skyscraper unlike any other. This is how it was built. Okay, let's get one thing straight. This building, designed by Zaha Hadid Architects, would not be possible without modern-day technology, specifically the computer software that architects now use to design buildings. Or rather, it could maybe have been possible, but it would have been a lot more expensive and taken decades to finish. Now, one of the reasons for that is because of the incredibly intricate glasswork that you see on display here. Each panel not only has a unique curve, but some of the panels curve in multiple directions. Combine that with the fact that the panels themselves consist of 4 panes of glass inside them. This means they had to be made perfectly and exactly the same 4 times over. This project is not only an incredible feat of design, but an amazing feat of construction.
Henderson Tower is an incredible building that really stretches the boundaries of what we're capable to build with modern materials.
It's all very expensive too, and this building was not exactly cheap to begin with. The land for the skyscraper was purchased in 2017, and it made headlines around the world for being the most expensive site ever. The price came to roughly $965,000 for each square metre, or about $3 billion in total. All for what at the time was a parking lot.
Just because Hong Kong is already densely built, so there are not that many places left in the heart of Hong Kong.
And the site itself wasn't even that big.
It's a quite small size. It's a very small size. It's roughly 50 by 60 meter. Here in Hong Kong, every millimeter counts because of the comparatively small plot sizes.
The land lease came with the condition that 3 footbridges crossing the site would have to be retained. They would connect the building to the city's central elevated walkway, an extensive footbridge network that runs across Hong Kong.
It's elevated off the ground because there is a network of elevated pedestrian bridges running around this part of Central. So this is connected directly access to it. Also, it's adjacent to a garden and a larger park in the heart of Hong Kong. So it's a quite prominent location.
Now, while the skyscraper's organic curvy form is inspired by the Hong Kong orchid found in these gardens and on the region's flag, there is actually another reason for that voluptuous shape. Henderson Land wanted to offset the negative feng shui of the controversial Bank of China building next door. Now, that tower was heavily criticised for its sharp edges and use of crosses, both of which are bad feng shui. In fact, the Bank of China building is one of the only major high-rises in Hong Kong which flat out ignores feng shui principles. Apart from that, it was also just good design to balance out the stiffness of the building's neighbours.
We have this kind of a heavyweight neighbors around, like very famous as well, right? Like the Bank of China, the Lipo Center, which are though a little bit more like tough and rigid looking, right? So our response to this was we tried to get this one smooth monolithic object to balance and suit the presence of the prominent neighbors around.
The result is a building with a facade that is 20% curved glass. The tower is clad in more than 4,000 panels of double laminated glass that between them have 1,000 different curvatures. That's a lot of curves. You might also have noticed that curves don't appear that often in skyscrapers. They tend to be made of flat walls with rectangular rooms inside. Now that's because curves are expensive. Really, really expensive. And that's because they're really, really difficult to produce.
The actual appearance changed a lot, of course. We started with a little bit more curvaceous scheme, right? A little bit more unrestricted.
Things only got more complicated as the design evolved. Every time they changed the curvature of the facade, it also changed the floor plate.
Because of the form of the building and the small size, that means that changing, let's say, panelization width or radius, this immediately changes the floor area as well.
The whole process was incredibly intricate and wouldn't have been possible without state-of-the-art CAD software. So they brought in the big guns. This is the Guggenheim in Bilbao, Spain. It was designed by Frank Gehry, and when it opened in 1997, it was hailed as a masterpiece, one of the greatest works of contemporary architecture. It quickly became a touchstone for the deconstructivist movement, and helped lead the charge for a lot of what we see in architecture today, a playfulness with physics, flamboyant designs, and lots of curves. CATIA was the software used on the Guggenheim and for many of Frank Gehry's works, so it only made sense to use it here too.
We took the decision at a very early stage to move to CATIA. The advantages are it's software with a very precise control, right? So it allows us to model everything in very high precision. We try to predict as much as possible, so basically that's why everything was checked in 3D before being even tendered out.
The software had another surprising advantage too. It was originally used to design planes.
Right, CATIA was originally developed to model and engineer airplanes and automobiles. Those surfaces require really precise control. So the Henderson project, considering the geometry of the surfaces, the geometry of the facade, it requires the same control, the same capability within the software so that they can be manufactured.
Now, in many ways, this skyscraper was designed like a plane. From a distance, it might look like a complicated model with lots of aerodynamic curves. And don't get us wrong, it is. But it's also easily broken down into individual component parts and can be manufactured piece by piece, just like an aircraft.
Within CATIA, you have this capability to have extreme surface control to ensure that the surfaces that you're modeling in 3 dimensions can be manufactured.
That made it possible to engineer the curvy glass that was needed. Only 2 companies in the world could produce this incredibly complex facade, and a supplier was chosen all the way over in Germany. That meant the architects having to send these 3D models to the other side of the world, the glass being carefully manufactured to exact specifications, and then being shipped all the way back to Hong Kong.
Every panel had to be fully prefabricated in factory and then perfectly matching when assembled on site.
Because of the enormous demand for these intricate curving glass panels, the glass company built digitally controlled furnaces,
which would allow them to produce with very high precision almost any curved shape.
The glass at the Henderson also had to be strong, very strong. During construction works, a typhoon hit the city.
Hong Kong is bracing for the arrival of Super Typhoon Seele.
These flash floods break century-long records.
I've never seen a scene like this before. Even during previous typhoons, it was never this severe.
Fortunately, that was like very early stages of the construction process, so glass was not there yet. But was a lot of scare, right? The building regulations are quite strict because of the particularly high wind loads in Hong Kong.
That's partly why they went with heat-treated glass. It had to withstand higher than typical wind loads. The skyscraper has a few other quirks too. The building has an offset core, meaning the part of it that contains all its services, including lifts and stairwells, is in a corner rather than in the centre of the tower as you'd find in a more traditional high-rise building. To support the building, there are instead 6 mega columns. That allowed for a massive open floor plan inside, offering sweeping views of the Hong Kong skyline. This video was sponsored by CATIA from Dassault Systems on the 3D Experience platform. You can learn more about that at the link below. You can learn more about this and the other topics on our channel over on the World's Best Construction Podcast, available now wherever you get your podcasts. And as always, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.